Welcome to Rod's Radios. This radio came in the post today as a result of winning an online auction, and it's a Grundig Satellit 2000 transistorized radio from 1973, and a fine piece of German engineering it is, and it's something I've been looking forward to getting. This is going to be a bit of a challenge perhaps, because as described in the original description, the radio doesn't work very well on FM in that when you turn up the volume, the sound distorts, and on any of the AM bands, there is no sound at all. So I can show you what it actually sounds like by switching on and turning up the volume, and we'll see. So as you can see, it sounds as though perhaps the speaker could be faulty, or if not, there could be some serious problems in the audio stage. Likewise, when we select one of the AM bands, say medium wave for instance, and turn up the volume, it's dead, completely dead, no response at all. Likewise on shortwave 1 and 2, which is here, no response. And if we switch over to shortwave 3 to 10, which is operated by a turret tuner adjustable here on the side, a little bit of noise, which is encouraging I suppose, but no stations. And in actual fact, the turret tuner is stuck at this point, which is going to need some freeing up. But when you select the other bands here, just completely dead. So this is going to need some TLC, I think. However, cosmetically the radio is in extremely good condition. It looks superb, considering this is what, the bones of 47 years old. So I think it's time to take the back off and have a look inside and see what is going to appear. I've taken the back off the radio now at this stage, and the only thing I've done so far is to replace two of these dials on the turret tuner, which had fallen out of place and were causing the turret to get stuck as you turned it around. But other than that, I'm just having a look inside, and as you can see, there's quite a lot in this radio. You've got mains coming in here, there's a big transformer tucked underneath there, and AC comes out here and is fed to the power supply, which I think is in here. There's two fuses there, and up here we have the audio output stage with the two fat transistors on the top. Other than that, ferrite rod aerial here, FM IF stage up on top here, AM IF stage here, and down here I think is part of the shortwave band spread that allows you, while selecting some of the shortwave bands here, to expand them out and tune in on just a very small area. Big telescopic aerial here, capacitor tuner there, FM tuners down here. One thing I did notice in certain places, particularly when I had these two plastic covers off here, I can see where some of the trim pots have been adjusted. An example of that is also up here in here, where you can see tiny little scratch marks, which would have been from presumably a screwdriver adjustment. And one thing that concerns me is this core in here looks as though it's broken. They're very delicate and very easy to break. So this could give me somewhat of a challenge to get this thing up and running again. However, the first thing I want to do is to check whether the loudspeaker that I thought might be faulty is working or not. And what I'm going to do is plug in an external speaker here, which will cut out the internal loudspeaker here, and hopefully identify whether the internal speaker itself is faulty or not. So let's see what happens when I do that. I've plugged in an external loudspeaker now to see if we can isolate the problem as to whether it's the loudspeaker or the audio amplifier. And if I turn up the volume here, As you can probably hear there, the distortion is still there when the sound is turned up. Strangely enough, it only occurs during loud bass sounds. In the case of speech, if I tune onto one of the other stations,
I was told the Dáil that a bill to help tenants who have lost income due to COVID-19 will provide the 10th next year. However, opposition...
It sounds okay, but yet when I select something with a lot of bass in it, there's quite a lot of distortion on the bass notes. So I've isolated the loudspeaker, it's not that, so it must be something in the audio amp. Perhaps electrolytic capacitors need to be replaced. So onwards and upwards. I've rigged up a signal generator to the tape input on the radio to check out the signal coming through the amplifier. So here we have the signal generator, and if we can focus in, yep, starting at a pure sine wave of 400 Hertz, that's an audio signal, middle to low range audio signal, and I have it connected via the speaker leads to the oscilloscope. And as you can see, we start off with a reasonably okay sine wave. So now I'm going to turn down the frequency in increments of 10 Hertz. So we start off at 400 Hertz, 390, 350, 310, 280, 240, 190, 170, and now you can see the sine wave really starting to clip at the top, and we go lower again, 140, 120, 110, 100 Hertz, and at this stage the sine wave is completely mangled, which kind of mirrors what I was speaking about earlier in terms of the bass sounds coming out of the radio. So going back up again, higher and higher, we go back to the pure sine wave, 300, 400 Hertz, and we're back to normal. So this indicates that definitely there's a problem with the AF amplifier, the audio amplifier in this radio, and that's where we start our work. This is the circuit of the power supply and audio output stage for this particular radio. And I've marked in green all the electrolytic capacitors which I decided to change because these can sometimes cause this type of problem. And so it turned out to be. And over here you'll see the particular capacitors that I've replaced. And over here I took note of the results. And as you can see, virtually every capacitor bar one was measuring at least 50% or even 100% higher than its stated value. So it turned out anyway that this was the cause of the problem. And before I show you how it turned out, I'll show you an example of the leakage through these capacitors as demonstrated on my capacitance leakage tester. This is an example of one of the capacitors under test. It's a 22 microfarad in the audio output stage. And as you can probably see, if we focus in on this, nearly 1 milliamp leakage at 16 volts. So this explains the reason for the distortion of the sound. So let's have a listen to see how it sounds now. Having replaced the capacitors, I now have the signal generator connected back up again. And again, starting off at around 300 Hertz, sine wave looks fine. And now I reduce it down to 250, 240, 200 Hertz. Okay, so far. 150, 140 Hertz. 100 Hertz, no distortion. Down to 70, perfect sine wave. So, we have a result.
have to live there to work, but if that's...
Much better. Much, much better. At this stage, I think I'll close off this episode. I now have the sound working perfectly in FM, and the next phase will be to tackle the AM section. But that's a story for another day. Keep in touch.